In 2005, being cool was directly proportional to the number of MySpace friends you had. 19-year-old Samy wanted to be cool, so a Chipotle burrito bowl and a few clicks later, Samy came up with a few lines of cleverly designed code that, when pasted into MySpace, did something magical. Every time someone visited his profile, they would inadvertently add him as a friend and immediately make a public post saying, "Samy is my hero." This post had the same exact code which made anyone visiting their profile add Samy as their friend, and replicate on and on and on. 5 hours later, Samy had 1 million friends. He was cool. How did Samy's virus work? Can I hack my friend's Facebook account? Or just how does one even start hacking things? Hacking is actually really simple, and really fun to understand. Let's try to understand hacking by trying to hack a coin sorting machine, also known as a vending machine. In normal operation, a vending machine accepts coins of various values. The machinery inside must be using some logic to figure out that a coin is not fake. So essentially, this is a machine that takes in an input and tells us whether the machine accepts our coin or not. The first step to hacking is giving this machine a set of inputs and record the outputs in an effort to understand how it works. We'll give it a lot of random inputs. What if we put in a smaller coin? Nope, that doesn't work. What if we put in a coin made out of paper? That doesn't work either. This means that the machine must be checking for size and whether the input is a metal. We do this multiple times to figure out how it works. Probably putting in a paper coin with a smaller metal coin glued together would trick the machine. And it indeed does. This is the way hackers hack. They probe the system with weird and interesting inputs and try to create inputs that work to trick the system. So the main system we're trying to trick is the internet. Therefore, we must understand how it works. To keep it simple, think of the internet as this long connected wire that all computers share. They can refer to each other by addresses assigned to them, and you can send messages to any address on this network, and they can reply back if they want to. So Google isn't really a magical thing that appears from the cloud on your screen. Google is a computer on the network, sitting somewhere in California, waiting for your messages. When you type in google.com, your laptop sends a message to the computer whose address is google.com. Google then sends you back a message. The contents of this message is a document written in HTML. HTML specifies how text and images are styled on your screen, which your web browser reads and displays. To recap, you send Google a message saying, "Hey, give me your homepage," and Google sends you HTML so that your computer can display that page. Now when you type in a search query, you send a message to Google saying, "Hey Google, can you search for funny cat videos?" And then the computer at Google sifts through all the documents it has, matches them with your query, ranks them according to relevance, and constructs an HTML document that would present these results. Then it sends the document back to you. The computer that processes these requests and serves you these web pages is called the server, and you, the person requesting these web pages, is called the client. So how does this work in action? Alright, you type in the domain name of the website, say capitalize.com. The server then sends you back an HTML document, but most websites also send you some client-side code, typically written in JavaScript. The HTML and JavaScript are really simple. This line asks the browser to put a text box on your screen, and this line asks to put a button. The JavaScript below it waits for you to click the button, and then fires back a request to the server with the data you entered in the text box. Once this JavaScript gets back a result, it displays it on the screen using this line. Now to handle this request sent by a client, servers run code to process them. All code that is run on the server is called server-side code. This is an example of server-side code. This snippet takes parameters from the request, in this case a string of characters, capitalizes every character, and then returns back an HTML page with those characters capitalized. So when I input stuff into my text box, the server comes back with the capitalized version of that request, and displays it on the screen. MySpace worked in pretty much the same way. They ran a server, and a user could leave posts on their profile. Kinda how Facebook works. I'm gonna explain the rest of the hack using Facebook, because none of us actually use MySpace. On Facebook, you can tell all your friends what's on your mind. When you hit the post button, the JavaScript sends a request to the Facebook servers to update a list of your posts. And when other users open their news feeds, the server sends them a list of all the posts their friends have been putting up. Let's move on to the interesting bit of hacking. finding vulnerabilities. Now that we know how Facebook works, we'll try to see how we can break it. What if I put this in a post? Anyone who would see this post would instead see the text bolded out. That's pretty lame. Let's see what else we can put in. Aha, this piece of JavaScript will be executed every time someone looks at my post. What does this do? Well, if this JavaScript is executed, it clicks the like button on all the posts in their newsfeed. That means that anyone who looks at my post will automatically like it, and also like every other post that's visible to them. But don't get too excited. Facebook escapes JavaScript code in post to prevent this from happening. Back in the day, MySpace did not, and that's exactly how Samy's virus spread. This vulnerability is fancily called XSS, or cross-site scripting. When you write code that gets executed on some other user's machine and make them do stuff, you'd exploit XSS. Let's look at the classic Hollywood scene, hacking security cameras. The first thing we're going to do is go to showdan.io, a website that allows us to search for devices that are connected to the internet. We narrow our search to security cameras around my campus and select a camera you want to attack. This one's perfect, but is password protected. But luckily on the login page, it tells me the exact model of the camera. A quick Google search reveals that the manufacturer has put the firmware update files for anyone to download. This means that the camera has made it very easy for us to understand how the software works, since the manufacturer has essentially given me the very software they run on the camera. We use a tool called Chemo to emulate the camera on my computer, and a tool called GDB to reverse engineer the code behind the software. Looks like they're using a server, much like the one we've seen in the case of Facebook and MySpace. The server they run have a lot of different functions. If I go to /login, it sends me to the login page. If I go to /camera, it should show me the live camera view. But since I never logged in on the login page, it denies me access to the camera page. There seems something weird about how this login route works. Normally, the way this would happen is once a user types in some credentials, it would go to this page. But then the server replies back saying, username test123 does not exist. This means that we can get it to echo back whatever we send it in our username field. Without going into the complicated code behind how this is implemented, the computer essentially copies the string of characters we supply and send the copy back to us. This copied string of characters must reside somewhere in the computer's memory, which stores information about thousands of other users or clients that may be communicating with the server. If I lie to the server about the length of the username string I send it, that is, that I still send it 7 characters, but I lie to it and tell it that I'm sending over 50 characters. What will now happen is that the server in its response will send me back the original test123 string, but also copy over another 43 characters from its memory, giving me critical data about other users, possibly including the admin credentials. This sort of an attack is called a buffer overflow attack, and was the cause behind the famous hartbleed security bug that affected almost 500,000 websites, including sites like Reddit and Wikipedia. A lot of stuff around us is a computer. Cameras, phones, cars, airplanes, pacemakers, nuclear enrichment centers all heavily rely on computing. And computers are crazy complex machines that, if not designed perfectly, are easy targets for hackers. But hacking isn't really about getting access or stealing or destroying information. It's about understanding, about probing, and about the thrill of discovery, while making us all safer.